This video looks at chemical bonding. So there's two types of chemical bonding we're going to look at. The first is intramolecular, found in pure substances, and it's within atoms in a molecule, and it's connected by electrons that are shared either in a covalent molecule or electrons that are transferred in an ionic molecule. The next type of bonding is intermolecular, usually found in mixtures or when you have two or more molecules sitting side by side. And this is between different molecules. And these are called London forces. And we're going to talk more about this in chapter 9, where we learn about dipole forces and hydrogen bonding. So let's look at the first type of bonding. The first type is intramolecular, and there's two types. So there's ionic bonding and then there's covalent. So ionic bonding is when you have a metal and a non-metal that combine, and there's positive ions and negative ions. The reason why you have a positive ion is because one of the elements in the compound has given its electron away to the other element. So here sodium gives up one electron to chlorine, which then has 8 electrons outside it, and it's considered stable. So here is the reaction right there. So it's this region of space that we're referring to that is the intramolecular bond. So this is the ionic bond, and it's intramolecular. Now, covalent bonding is between non-metals only, and it's when electrons are shared to become stable. So when we say stable, we're talking about having that closed outer shell. So both chlorine atoms here need one electron to get 8 valence electrons in their outer shell, so they simply just share. So this region of space is your covalent bond, and we can also call it an intramolecular bond. Here, what we have here is just a more detailed example. Let's say we have CH4. So this bond right here is the intramolecular. So I'll just highlight the intramolecular. So it's within the molecule. So this region of space, on the other hand, when it's between different or the same molecule, so this area right there, that is what we're going to look at next. That's an intermolecular bond, and we'll talk more about that in a second. So this region of space here that I highlighted first, the covalent bonds, these covalent bonds are very strong, and they have most covalent molecules have very high melting points. And the individual atoms in a molecule are held by strong covalent bonds. Now, the bonds holding the separate molecules of CH4 are actually weak, and they can be broken much more easily. Okay, so there's no electrons involved there, really. So intermolecular bonding, also known as London forces, it's simply the region of space between molecules. Just think international is global, so it's between the different molecules. This region of space is very weak and not strong. London forces fall under the category of van der Waals forces. You'll read more about this in your workbook, but the main takeaway is that region of space is called a London force. In chapter 9, we're going to learn that atoms can be polarized. You can create these partial charge separations due to electronegativities, different electronegativities of the elements that are joined together. You can also, and it's also known as more of a temporary magnet when you create this charge separation. So this is all chapter 9. So we'll look at this in the next few videos later on. So if we look here, the London forces is just the region of space. Oh, let me use the same color for here. So these are all London forces happening right here. Okay, the London forces are stronger as the molecule is closer together. If the molecule moves away, the London force gets weak. So let's say we take this and we move it away. Then the London force that was acting in between there um, gets really weak, if it's even there at all. Okay, so the farther a molecule is, the weaker the London force. And the closer the molecule is, the stronger the London force. So if we move this back, let's say the water molecule in a solution is beside it, then you can say that this region of space right here, this London force is now stronger. Okay.